Kinematics of motion in a straight line. This is lesson number 3. These are related graphs of displacement, velocity, and acceleration. Look at this first set of graphs. On the left hand side, the graph is between acceleration time or horizontal line shows the constant acceleration. This is a horizontal line. Suppose this is 2. This is 2. This means that acceleration is constant. The related graph of velocity time will be a inclined line. ये देखें inclined line बनेगी. तो next set of graphs number 2 is of velocity time and displacement time. Suppose on the left hand side the graph is a horizontal line. Suppose this is 2. This means that velocity is constant. Then the related graph of displacement time graph will be an inclined line making an angle with the x-axis. Number 3, the set of graph is between acceleration time and velocity time. On the left hand side, in acceleration time graph, line is inclined making an angle with the x-axis. Then the related graph, in this the line and acceleration is uniform, and the related graph of velocity time will be a curve, quadratic curve. ये देख रहे हैं acceleration time में ये straight line inclined line हो तो उसका related velocity time graph जो होगा वो एक curve होगा. In this graph the graph is a quadratic. And the number 4, the fourth set of graphs is between velocity time and displacement time. If the velocity is uniform, आप left side पे देख रहे हैं graph is between velocity and time, it is an inclined line. Then the related graph of displacement time graph and the displacement time graph will be a quadratic curve. हॉरिजेंटल लाइन से वेलोसिटी टाइम रिलेशन में इंक्लाइंड लाइन हो तो उससे उसका रिलेटेड ग्राफ डिस्प्लेसमेंट टाइम जो है वो एक कर्व बनेगा. आप देख रहे हैं दिस इज़ अ क्वाड्रेटिक कर्व. नेक्स्ट कॉन्सेप्ट इन दिस काइनेमेटिक्स is the differentiation, how the differentiation and integration in kinematics. Differentiation and integration in kinematics. And displacement, first box में displacement है, second is velocity and acceleration. Displacement is represented by S. This is S. S for displacement, and V for velocity, A for acceleration. If we differentiate S displacement with respect to T, we will get a velocity. Then if we differentiate velocity with respect to T is time, then we will get acceleration. And since the differentiation and integration are reverse process to each other, then if we integrate this acceleration with respect to time, then we will get velocity. This arrow shows arrow that shows the direction of that arrow is on the left side. This shows if we are integrating a with respect to t, we will get velocity, and then if we integrate velocity with respect to time, then we will get the displacement. So एक्सेलेरेशन को इंटीग्रेट करेंगे तो वेलोसिटी को इंटीग्रेट करेंगे तो हमारे पास डिस्प्लेसमेंट आ जाता है. लुक एट दिस एग्जांपल नंबर 1. ये एग्जांपल से मोर क्लियर हो जाएगा. एन ऑब्जेक्ट, एग्जांपल नंबर 1, द स्टेटमेंट ऑफ द एग्जांपल इज एन ऑब्जेक्ट मूव्स अलोंग ए स्ट्रेट लाइन so that its displacement after t second is given by s is equal to 2t cube minus 6t. S displacement, t is time. Find expressions for the velocity and acceleration of the object at time t. So this is a displacement time relation. S is equal to 2t cube minus 6t. We are differentiating s with respect to t. This becomes ds over dt. ds over dt जो होता है वो velocity होता है. तो जब डिफ्रेंशिएट करेंगे तो ये डिफ्रेंशिएशन के रूल का हमें पता है. 3 जो है वो 2 के साथ मल्टीप्लाई हो जाएगा, पावर एक डिक्रीज हो जाएगी, तो दिस बिकम 6t स्क्वायर माइनस 6. तो सो वेलोसिटी हमारे पास, वेलोसिटी एक्सप्रेशन हमारे पास आ जाएगी v इज इक्वल टू 6t स्क्वायर माइनस 6. नो इन द सेम वे इफ वी आर डिफरेंशिएटिंग v विद रिस्पेक्ट टू t, तो दिस बिकम्स dv over dt which is equal to acceleration. तो then this becomes 12t. वेलोसिटी को डिफरेंशिएट किया तो हमारे पास एक्सेलरेशन आ गया. सो एक्सेलरेशन इज 12t. दिस इज द एक्सेलरेशन एक्सप्रेशन इन टर्म्स ऑफ t. Now next is the example number 2. The statement of the example is the acceleration of a particle at time t at time t second is given by this relation a is equal to 6 minus t. The particle is initially at the origin with velocity minus 2 meter per second. ये देखिए, this is the initial conditions of the movement of the particle. This is called the initial conditions. कि initially a particle is initially at the origin with velocity this. यहाँ पे t 0 होगा और velocity minus 2 meter per second है. We have to find the expressions for velocity of the particle. Number 1, velocity of the particle after t second. Number 2, displacement of the particle after t second. So this is the relation. A is equal to 6 minus t. A is acceleration, t is time. If we are integrating, first we can write a को हम लिख सकते हैं dv over dt is equal to 6 minus t. Now integrating each side, जब हम dv over dt को इंटीग्रेट करेंगे that becomes v, और राइट साइड को हम इंटीग्रेट करेंगे 6 माइनस टी को विद रिस्पेक्ट टू टी. तो 6 की इंटीग्रेशन होगी 6t और t की इंटीग्रेशन होगी t स्क्वायर ओवर 2 प्लस cc must be there because the limits are not given. So this type of integration is indefinite integration. Then we must have a c where c is the constant of integration. You have studied this in the chapter of differentiation already. in paper 1. Initially, these are the initial conditions. T is equal to 0 when V is equal to minus 2. So we will put these values T0, V minus 2 in this equation. We will get C is equal to minus 2. We have found the value of C minus 2, or putting the value in velocity time relation, we will get V is equal to 60 minus T square over 2 minus 2. This is the velocity time expression. Number second, we have to find displacement of the particle after t second. Again, we will use of process of integration. V is equal to 60 minus t square over 2 minus 2. We can write V as ds over dt. V को हम ds over dt लिख सकते हैं. And this is 60 minus t square over 2 minus 2. Now integrating. If we are integrating ds over dt, this becomes s. On the right hand side, we have to integrate 60 minus t square over 2 minus 2 with respect to t. तो 6t का बन जाएगा 6t square over 2 minus 1 over 2, और t square को हम इंटीग्रेट करेंगे, दैट बिकम्स t3 over 3, और माइनस 2 की इंटीग्रेशन 2t है, प्लस c. वी आर अगेन टेकिंग c as a constant of integration because the integration is indefinite. नो 6 और 2 ये कैंसिल आउट हो जाते हैं, यहाँ पे 3 रह जाता है. तो दिस बिकम्स s is equal to 3t square minus t cube over 6 minus 2t plus c. Now we have to find the value of c by using the initial conditions of the questions. The initial conditions are these: when t is equal to 0, s is equal to 0. So putting here s is equal to 0, t is equal to 0. Also the value of c is 0. Now putting this value of c in the above displacement time relation, we will get s is equal to 3t square minus t cube over 6 minus 2t. This is a displacement time expression. Next concept in this kinematics: motion of a particle with constant acceleration. So when the acceleration is constant in your question, you will use these three very important equation of motions. And yeah, you can say that formula for the horizontal motion. इसमें horizontal motion को भी देखेंगे और vertical motion को भी देखेंगे. For the first for these first three equations, there is a horizontal motion. ये horizontal motion के लिए v is equal to u plus at. Number 2, s is equal to ut plus half at square. Number 3 is v square minus u square is equal to 2as. So this is the horizontal motion. These equations will be used for horizontal motion. The next, the formula for the vertical motion, या आप कह सकते हैं the equation of motion for the vertical equations of motion for vertical movement of the particle. So these equations are v, first is v is equal to u plus gt. अब हम a नहीं लेंगे, vertical motion के लिए g यूज़ करेंगे. g is the acceleration due to gravity. Second is s is equal to u t plus half g t square. And the third equation of motion is v square minus u square is equal to 2gs. Where g is the acceleration due to gravity. g is acceleration ड्यू टू ग्रेविटी और इसकी वैल्यू मैकेनिक्स में हमने 10 मीटर पर सेकेंड स्क्वायर ही लेनी है. नो remember it that for upward motion of the object the value of g will be negative 10 meter per second square, and for downward motion the value of g will be positive 10 meter per second square. Where in these three equations of motion u represents the initial speed of the particle and its unit will be meter per second. V represents the final speed of the object या particle, its unit is meter per second. Acceleration of the particle is represented by unit of that is A represents the acceleration of the particle and unit is meter per second square. S is the distance or displacement, its unit is meter, and time t for time is in second. तो यहाँ पे आपने याद रखना है कि इन द क्वेश्चन स्टेटमेंट वर्डिंग विल बी यूज्ड फॉर अपवर्ड मोशन. वर्टिकल अपवर्ड मोशन के लिए स्टेटमेंट होगी एन ऑब्जेक्ट इज प्रोजेक्टेड वर्टिकली अपवर्ड, एंड फॉर वर्टिकल डाउनवर्ड मोशन के लिए स्टेटमेंट होगी अ पार्टिकल इज रिलीज्ड एट अ डिस्टेंस. कोई डिस्टेंस दिया होगा, ए पार्टिकल इज रिलीज फ्रॉम हाइट से 100 मीटर. पार्टिकल जी इज रिलीज तो इनिशियल स्पीड उसकी 0 होगी. when the particle is projected vertically upward, so then the speed of the particle will be given. when the particle is released from a height, then its initial speed is 0.